All right, thank you, Mike. Good morning, everybody. This is Matt Beitcher from WFO St. Louis. Thanks for joining us for the for this week's guest speaker series. We've got a couple of really great presenters to talk to us about the National Fire Danger Rating System, the NFDRS, excuse me. We have Bennie Terrell, who is Forest Fuels Planner for the Mark Twain National Forest right here in Missouri, one of our partners here in St. Louis. He's based out of the supervisor's office in Rolla, down in Springfield's area, and has got over 21 years of experience in wildland fire and fuel management with the U.S. Forest Service and the U.S. Department of Agriculture, and is responsible for the prescribed fire planning for the forest, wildland fire incident management, fire and fuel data for the state, as well as a few other things, and also represents the Forest Service on the Missouri Prescribed Fire Council. We're also joined by Steve Marien, who actually was a Weather Service employee from '93 to 2001, such places as WSO Madison, and then WFO Wichita and Louisville, and was the assistant fire weather focal in Louisville from '98 until he left the agency in 2001 to become the predictive services one of the predictive services meteorologists at Eastern Area GAC from June of 2001 to present. And he produces fire weather and fire danger products to assist the interagency fire community with resource decision support, assist the community with the transition to the National Fire Danger Rating System version 4, and also acts as a liaison between that interagency fire community and the National Weather Service. He'll be speaking a little bit later in the talk, but I'm going to hand it off to Bennie now, and he's going to give us an overview of the NFDRS from fuels perspective, and then we'll move on to Steve. So Bennie, floor is yours. Feel free to share your screen whenever you're ready.
All right, thank you for having me on. Thank you, Matt. Thank you, National Weather Service. This has been a long time coming. We wanted to get with you guys to talk about National Fire Danger Rating System and how it relates to the National Weather Service and the products that we get from you guys and the information that you guys put into some of the systems that we use, and how it relates to what we use on the ground when we're out on the landscape with wildland fire operations. And so the National Fire, bringing up my presentation now. Can you guys see my presentation?
I was able to see it a minute ago, but there it goes. Now I can see it.
Okay. So National Fire Danger Rating System is one of the systems that we use to do predictive fire behavior or fire danger rating, similar to, Steve will be able to speak to it, but it's kind of similar to some of the danger rating systems that you guys have in place for a warning for different type of weather events that are coming in the area. And we have the same thing, but ours is built off of climate, historical fire weather, and also historical fires, as well as the topography and the location that is being broadcast from. And so back in the 70s, they started developing some algorithms to kind of predict this for wildland fire. So when we were putting firefighters out on the ground, that they would have information in hand or information to predict what the fire and fuels climate, and not the fire and fuels forecast was for that day. And so just like you guys put out a similar weather events, they give us a forecast for the day. They wanted to have something. I'll be putting out information. I'll be presenting on the National Fire Danger Rating System, and then how the Mark Twain National Forest here in Missouri used the Fire Danger Rating System. And then Steve Marien, who is works in the regional office out of Minnesota, he'll be talking about the predictive services areas, some of the graphs and charts that he used, and then some of the new science and technology that is starting to onboard and replace some of the old systems that we've used in the past. So pretty much fire danger rating system, like I talked about earlier, is to develop consistency among protection agencies. National Fire Danger System was developed in the early 70s. It was designed around four basic guidelines to research. Charter said that the National Fire Danger Rating System would be scientifically based, adaptable to the needs of local managers, applicable anywhere in the country, and reasonably inexpensive to operate. And so out of the Missoula Fire Lab, there's two individuals currently responsible for the National Fire Danger Rating System. Is Matt Jolly and Faith Ann Haish, and they're responsible for the algorithms as they come up with the new information and to move us into the future with fire danger rating systems. And so the components of the fire danger rating systems, they want it to be modular. New science can be easily added, and so it's always growing. They're always developing. We'll show later on in the presentation how we've gone from 78 to 2000s in the new system that we currently use now. Integrative fire danger indices integrated over both space, and when we talk about space, the FDRA, that's a fire danger rating area. That's pretty much an area on the ground that are managing for fire danger in those areas. So for example, like in Missouri, we could be covering the Ozarks instead of covering the whole state of Missouri, and that Ozark would be considered a fire danger rating area as opposed to the northern plains, everything that's pretty much north of I-70. And so multiple times, horizons, today, seasons, and interannual. And so it wanted to be generalized, so you can use this system pretty much across the nation, and the same system to perform across a range of climates, and it will work everywhere. And so they have it set up where you have 5 fuel models that can be used across the nation. And then also the weather parameters and the climate information that comes in there, we get that from historical information, as well as products that we get from the Weather Service. And that's, the drought monitor information, and then also some of the RHs in the historical temperatures and RHs, and that type of information. They wanted to be applicable, normalize index scales, and apply indices across the spectrum of fire management decisions and maintain a common language across the agencies. And so they didn't want one agency producing a fire danger rating, and then, for example, the U.S. Forest Service, and then you have the Department of Interior have two different fire danger rating systems, and then they're operating on the same fire. So they want to speak the same language to all firefighters and across all agencies as they're looking at the same piece of ground or the same climate or weather event that is occurring that day, and what fire behavior will come from it. So here's an old chart here. This is the 78 model, how we started out, and you can see in that chart, I know some of it is small, but the top blue part, if you can see on the left side of the screen there, the inputs, those are all the inputs that go into the fire danger rating system. And so you can see live fuel, moisture, fuel model, slope, latitude, and annual average annual precip. And then you can see what goes in daily. What goes in daily is the information that we pull from the weather stations. And then 24-hour observations, and those are the averages of the 24 hours, and those would be the mean and the max. And then other inputs, carryover, fuel moisture, and those are related to the fuel sticks, curing dates, and things like that. And those information feeds into what we calculate. And so we calculate here. You can see that word there that says KBDIs. I know there are going to be a lot of acronyms here, and I'll try to explain what they are. The KBDI is our drought index as far as fire. And then you have the 1 hour, 10 hour, 100 hour, 1,000 hour. Those are our fuel sticks. And so that's the fine dead fuel that's on the ground, twigs all the way up to logs that's laying on the ground in the woods that could become available to burn depending on the curing and the drying of that fuel stick. Then you have the live and you have the live woody. And so with the live herbaceous, you're talking about the grasses and the forbs and things of that nature. And then the live woody, you're talking about vegetation that is like the brush or bushes and things like that, the lower lying vegetation that's woody in the forest. And as that cures and dries out and becomes readily available for fuel, that can add to the fuel load. And then if you can see below there, it talks about how they're weighted, and those triangles are showing how they're weighted based off of the outputs. And so the outputs below there are in red, and those are the outputs that we use to produce the products that we use for fire warning or fire watches, as far as if you want to relate it to some of the products that you guys put out. And so ignition component is pretty much as the fuel dry out that day, if it was to receive an ignition source, would that fuel ignite? And spread component deals with how quickly the fire was spread in an area. And then a burn index. And the burn index deals with inputs that are wind related, the drying of the fuels. And that burn index will, if that fuel was to light that day, how readily would it burn? And burning index would be the characteristics that you would get from it, like a flame in front, flame lengths, and flame heights. An energy release component, that's the amount of energy that fire is producing. And so that's going to speak to the amount of fuel that's in there and the amount of fuel that's burning. But back in 2016, I believe, we converted from the 78 and the 88 model because there was some deficiencies with it across the nation. And so they went back in and started to look at the holes that was in the system and thought that how could they generalize the information a little bit more and make it less convoluted, a little more easier to use, and adding new science into it. And so this is the new structure, and you can see that the inputs are still there, a little less information. Fuel moistures are still there. They went from, I believe, 22 fuel models back to 5. And in the beginning, they had 5 fuel models, but as you start to add other partners and other groups into it, they thought that they needed fuel models that were based off of their site-specific locations. And so they went from those models because there wasn't it wasn't a lot of information that was much different from the different fuel models. And so the fuel models that we do have is grass, and we have a grass and shrub one. And then we also have, a timber one, and then we have a slash one, and I believe we have a grass and shrub combined. And so those are the fuel models that are being weighted. And so if you can see, there's the ignition components again, spread components, burning index, and energy release. But also you can see at the bottom of this screen, some of the products that are created from those indice charts that we use. And we'll talk about that later when we get into Missouri Fire Danger Rating System. But you can see the Fire Danger Operating Plan there. And so those products that we use help us develop our staffing plans, our preparedness plans, our restriction plans. And restriction plans, we're talking about if the burning index is high or energy release index is high, then it may restrict campfires, or it may restrict public use. And then also you have the prevention plan, and the prevention plan is in place when we have ongoing wildfire, or we're in a drought, or we're in a severity moment where we can't have any fires. And so what does that information look like that we're giving out to the public? That's our prevention plan. And communication and situational awareness tools, and that's the information that we provide to our firefighters and the people that's out in the field. And so you can see also the annual operating plan, the initial response, and that's here at dispatch. Our office is set up just like the fire department. And you know how the fire department, as far as a structured fire department, they get a call in and they have a fire and they respond. We have the same similar setup here, where we look at the indices, we look at the charts, and we know what we're going to have that day. And so we have to staff accordingly. And our dispatch, based off the staffing, they will send, every time they have an incident, they'll send a response. And that response is the amount of resources they need to extinguish or to support that incident. And a mobilization plan is just a plan of how we move resources across the board. So here's a little bit more information to kind of break down. Here in Missouri, we use more of the burning index and energy release component. And so this kind of breaks down, gives you more generalized of what it stands for. And so different stages of fire is smoldering, creeping, and spreading. And then as it advances, it shows as it accelerates, it gets into a running stage, spotting and torching. That's what you see on some of the larger fires in California, where they're torching across the canopy and crown running and spotting. And extreme and erratic when, you know, anything that you can do outside as far as chainsaw work, road grading, any spark can cause a fire. And that's when you're in extreme conditions, when your fuels are that dry that they're so receptive to any spark or any ignition source. And that all feeds into fire behavior risk. And so fire behavior risk is what we try to predict, and what we try to put out as a warning system to people before they take to the field. They'll know what the fire is going to be. They'll know what the fire environment possibly will be, and they will plan according to that as far as staffing, having the resources on scene as well. And when we speak of staffing, we talk about all the resources that you may have seen watching the news or watching the Weather Channel when they're talking about the bigger incidents that occur out west. That potential is here in Missouri, but we have to be in extreme drought. But we do here on the forest have resources that we'll bring in. We have helicopters, we have planes, and then we have resources as far as engines and dozers, and then the firefighters that's on the ground. So information management systems, it consists of our RAWS weather stations. I know a lot of you guys use those RAWS weather stations across the nation. And so our RAWS weather stations are the remote automatic weather stations that most of them are through a company called FTS, Forest Technology Systems. And so they gather the data that we need, and then that data is uploaded in our WIMS program. And WIMS is a weather information management system, and that's the program that you guys use to upload your information, and Steve will be able to speak to it. And it produces weather outputs for us, and then those weather outputs feed into the algorithms that's built in the system to feed into the indices, and then also spit out indice outputs, and then that indice output will be able to let us send out a fire weather forecast for the area. And that's what WIMS is about as far as us. But we know in 2 years, we're going to go from WIMS to FIMS, and that's a fire environment management system. I believe that's what the acronym stands for. And that will be a more graphical display where you'll be able to go to a platform online, and you'll be able to see like currently, like if you can go on the weather national weather page, and you can see how the climate is changing, not the climate, but the weather is changing that day. That forecast will be changed as far as fire weather and severe fire weather, how that changed throughout the day in the new film system. This graph here shows how many weather stations, raw stations we have in the state, and where they're located across the state. So pretty much the state is covered as far as RAWS weather data that we need to download to predict for the reaches out across the state. And then, like I talked about earlier, Interagency Fire Danger Operating Plan, and our operating plan here on the Mark Twain has been in place since 2001, but we updated it back in 2021, and there should be an update coming in 2023 with the changes, the new information and science that's going to change in the National Fire Danger Rating System. But our plan is put in place, and this is some of the products from our plan. And so some of the products from our plan here is our staffing plan here, as you can see here. And you can see that we're using the burn index matrix and the ignition component matrix. And on that matrix here, you can see what the staffing looks like. And that's how we use those tools. And so you can see days that we have burning index of 0 to 6 and 0 to 4. We're staffing at a level 1. And then what that looks like to anybody out in the field that level 1 is on that chart. And so also here listed is how we operate as far as the weather when the weather does come in. And so the graph to the left, it talks about the fire agency daily operations, observations are archived, and that's archived through the WIMS program. And then roughly around 1,300 forecasters create a draft afternoon narrative forecast. And that information is fed into the system. And then we pull that information from the draft forecast that you guys put into the system, and we go into WIMS and we run a fire behavior forecast. And that fire behavior forecast gives us outputs as far as the indices. And when we speak of indices, like we talked about earlier, the burning index, the ignition component, the spread component, and the energy release component, which is the ERC. And that information goes out to the field, and the field is able to interpret that based off what's in the fire danger operating plan. So that's just a snapshot of what we do. We've worked a lot with the with our predictive services. We worked a lot with Springfield, St. Louis, and Paducah to try to get this information to them. I know that we do have our fire weather watches and our fire weather system in place where we have given them information to support the red flag forecast. But we dive into a little bit deeper because a lot of times fire weather is occurring even though we may not have extreme events going on that day. And so for people that we have out in the field, we still have to produce a product, and that's why NFDRS is so important. And I thought that this presentation would give you an insight on what we do on our side and how it relates to what you guys are doing. And with that, I'll close my presentation and I'll transfer over to Steve.
All right, thanks, Benny. Can you guys, let's see my screen?
Yes, we can. It's a story map.
Okay.
Now I got it.
Yep, you got it. Let me move that over. Okay, so just real quickly, once again, I'm Steve Marien with the Eastern Area Coordination Center. So this is our website, and they hired predictive services meteorologists around the country at all of the different geographic areas to facilitate, to kind of like you know, in the intro, to facilitate the movement of resources, kind of an assistant in resource decision management. So say like the Great Basin has a need for either equipment or crews and so forth. All the geographic areas coordinate the movement of resources around the country. So if we have folks in, say, Minnesota or Missouri that are available to go out west, that is all coordinated through these different geographic areas. Just wanted to explain that. And as far as the moving on to the NFDRS, Benny mentioned that, you know, he explained the update to the new version 4 system. And I just wanted to point out some of the things that go into the decision making. On the fuels and fire danger page over here, I've put together, you know, the new version 4, and the fuel model Y is the new new national standard across the country. So I run those just so we're comparing apples to apples with our neighbors to our south and west. So you know, and I've grouped these predictive service areas. They're fairly broad, but they're meant to give more of the bigger picture as far as fuel conditions. Benny, you know, with the Mark Twain in the state of Missouri, they're a little more focused in on all the individual RAWs around the state. But I use and like this predictive service area graph uses the Ashland and Ava raws as key raws, because we went through all the data, the weather data, and made a decision where are the most consistent data sets and as far as the historical duration. So this is essentially this data is showing 2010 through the 2022, and then I overlay the pink line is the current year, and these are the burning indices. So, you know, Bennie explained all the different fire danger indices that come out of the NFDRS system. Burning index has wind in, you know, as a component. So you'll notice that it jumps up and down quite a bit. So this one is more erratic, so to speak, or volatile. So you got a windy day and there's dry conditions, you know, RH and the fuel moisture is going to this as well. But you can see those, you know, oscillate up and down with the different winds for each day. And then, you know, the energy release component, not quite as volatile. So you can see it's been going up and down with, you know, a precip event comes in and drops them down, and then things dry out. So this is more, typically more of a medium range index to show you like the fuel conditions. So, and then I also put like the larger fuel moistures, the 1,000-hour fuel moistures. This is the current trace, and the red line is the historical minimum for those fuel moistures over this time period, with the current year overlaid. So most of these charts, you know, I'll have burning index, ERC, and 1,000-hour fuel moistures, and you can, you know, here's the southeastern part of the state. Has Sinkin and Doniphan, those two raws. And, you know, throughout this year, we're going to, you know, do myself along with a fire analyst and some other assistants, do a reanalysis of all of these, like you'll notice this 90th and 97th percentile breakpoint here, just to reanalyze all of the weather station data. And most of these predictive service areas after the reanalysis will have additional raws being computed in there. And all of these charts, I can show you guys if, let's see, come out of a program called Fire Family Plus. And all it is an Microsoft Access interface. So, you know, like here's all the different raws within the big rivers, which, you know, Iowa, Missouri, Indiana, Illinois, all of the key raws that I utilize. And then these are the different, so I just showed you guys the Eastern Area Predictive Service Area 12. Here's those two raws, the key raws, and then you can run these charts within this program. And I will try to update these on a regular basis, especially through the spring season. So this is another resource for folks, you know, if you guys are trying to make, you know, red flag warning, fire weather watch decisions, it's just another guidance tool. You can come in here and see what the ERCs are doing. Are they, you know, above average, the gray line, or are they pushing up towards the 90th and 97th percentile? And those, in the fire world, like people kind of think those as very high and extreme as far as like, you know, adjective rating, like the Smoky Bear is the setting on that. So that's just, you know, one of, you know, like Bennie explained in the FDOP, the Fire Danger Operating Plan, there's different things that come out of NFDRS that are utilized for various aspects in the fire community. You know, like staffing level would probably, you know, for internal setting the staffing, this burning index might be utilized for that. And then longer term, like preparedness levels, what may lean more towards the ERCs and 1,000-hour fuel moistures, which change much more gradually than, say, your smaller fuel size, like 1 and 10-hour fuels up towards 100-hour fuels. So that's just one aspect of NFDRS that I wanted to pass along to you guys. The other thing, just to update folks on, is, you know, Bennie discussed WIMS, which is the the computer interface where the fire community looks at the not only the weather obs that come out of the RAWS stations, but also that's where all the computations are done as far as fire danger indices online. So the dispatchers get in there and look at in WIMS to see what the say the ERCs or the burning indices are doing and how that affects their staffing levels and so forth. But the other eventually over the next couple of years, and we have FEMS is going to be coming online, and that is the fire environment mapping system. So this is going to eventually replace the WIMS system as your one-stop shopping as far as hourly weather data downloading. It's also going to incorporate the National Fuel Moisture Database, which is a system where folks, if they did fuel measurements, like actual live fuel measurements, they could enter those into that system. So folks around the area could look at what the actual fuel moistures are. So that the first step, that's being done right now is all of the hourly weather data is being quality controlled and gap filled from 2000 through 22, and that's occurring right now. And notice the 7-day forecast out of the Weather Service. So the FWM is I think experimentally has been going out 7 days for the past year or so. So that data is going to be fed into FEMS, similar to WIMS, and then they'll use that to calculate indices going forward in that interface. So as far, this spring, eventually, there's the historical weather obs, those will be available. The current obs from WIFME, which is the maintenance recording system, but also that's the main conduit that the data is fed from WIFME, from the satellites through WIFME into WIMS, and eventually once FEMS is rolled out over the next year and a half, WIMS will eventually be phased out. And there's those 7-day hourly forecasts from you folks in the Weather Service. So you can download the hourly weather data from the RAW stations, the permanent RAWs within FEMS, and I'll show you. And the other thing like I mentioned, the fuel moisture data will eventually be incorporated. That's one of the first steps that's going to occur in FEMS. That's set up for this spring. And Travis Vertican, who works with the state of Minnesota, is leading the charge on this fuel moisture database integration into FEMS. So and this, again, like I mentioned, FEMS is going to replace WIMS. Eventually, it's scheduled to by the end of this year. And it's basically going to, like I said, be a one-stop shop. So let me go to the next screen because I took this image and blew it up for you guys. So it's a little fuzzy because I expanded it out, but this is what it's going to look like. So here's your permanent RAWS data, these right here, and it's showing right now, this is just temperature, but you'll be able to look at, say those ERCs, burning index, the fuel moisture values, not only observed, but the forecast. So it's taking the FWM products from you guys in the Weather Service and using those forecasts to calculate out further those indices. And eventually, instead of being like point forecast, this will be displayed on a gridded basis. So we're moving forward into the future finally, and so you'll get a more spatial display of not only observed but forecast fire danger going forward. And eventually you'll be, if you want to, you can select a grouping of raw stations to look at that specific data, and then over here it'll display cards, is what they call them, on the right of, say, like similar information to what you get, what I just showed you guys out of Fire Family Plus. So it's going to take the aspects of WIMS, like the data management, viewing your fire danger indices, and also it'll have the ability of Fire Family Plus, that Microsoft Access database, that system to display graphically fire danger indices and so forth. So that's FEMS. I just wanted to get you guys up to speed on that. And it, all these different aspects will come online throughout 2023, and I believe it'll probably bleed into 2024, and eventually WIMS will be phased out. So I think that's, I guess the only other thing I was going to show you guys is on the outlooks page is the flagship of the predictive services group is the 7-day significant fire potential, and all this. So here's the eastern area. I'll expand it back out. This is just these values, the green, yellows, and browns are basically displaying forecast dryness levels. So in our geographic area, it's a combination of forecast energy release components and 100-hour fuel moisture, so a matrix. So there is, a text file that I import into the system, and it gives me the forecast dryness levels. These, green essentially means the fuels are, not that in play as far as availability, or they're, fairly moist. But then once you start getting into the yellows and browns, that means your ERCs are creeping up towards, that 90th percentile. There's breakpoints set within each of these predictive service areas. And that is indicating, just across the border, the southern area has, some dryness that's been going on. And, we've had this persistent dryness over parts of the southern into the high plains, but then just across my border, it's showing there. But you'll notice, on some of these drier days that are coming up early next week,
I think we may have lost Steve.
I was just wondering if that was me or if that was everybody else.
No, I think we may have lost Steve. Steve, Marien, are you still there? Yeah, I think he may have lost connection. But we can open the floor up for questions. I can answer some questions, and hopefully Steve will sign back on.
Sure, absolutely, we can do that. Let's see, Mike, I actually don't have access to any of the questions if anybody's sending you anything, or I can't even see the attendees. So if somebody's raising their hand, you're going to have to facilitate that.
No problem. No one's so far. Bennie, with the whole danger system, you're talking about, looking at day one. How far out do you go? Is it going out to 72 hours, or are you going out beyond that to figure out planning and mobilization for all your resources?
Yeah, so what Steve kind of was pointing out there, what we usually use is the data that you guys put into the 7-day forecast. We'll pull that data, and whatever weather inputs you put in that data, that we will start producing fire behavior or fire indices based off that data. So we try to predict out 7 days. What it's going to look like on the landscape, and I mean what it's going to look like 7 days out, as far as depending on the weather information.
Great, thanks. And once again, as Matt said, if you have a question, put it in the question pane or raise your hand and I will unmute you. And looks like we have Steve back. So we lost you at the end, Steve. So I don't know if you wanted to finish off the talk, or if you're, I don't know where it was.
Where did you guys? My network must have went down.
We lost you right around the time you were starting to use the interactive the map with the predictions going out a couple of days regarding the ERC.
Your 7-day potential.
This thing? Talking about this one?
I can't see your.
Hold on.
There we go. Yes, that.
This one? Okay. Dang it. I know I quit and then like no one was there and I'm like, uh-oh.
we heard to the point where you were talking about what the difference between the little to no risk, low risk, and moderate risk was, but basically beyond that, we lost you.
Okay. Dang, I apologize.
That's okay.
Well, are you guys able to edit this talk?
We typically, I don't think we do typically.
Okay. Dang, that stinks. It all messed. Well, anyway. Well, yeah, I was just explaining that, you know, there's data that goes into these forecast dryness levels, and it's essentially, you know, the forecast ERC and 100-hour fuel moisture. It's a matrix, and there's different breakpoints that go into each of these dryness levels. And so it's taking the FWM data from you guys in the Weather Service, and for the key raws within each of these predictive service areas, forecasting out the fuel conditions. And then, so it's another product that the fire community and you guys in the Weather Service could use to you know, if we start getting yellow, that means the ERCs are climbing up towards those critical levels, and then the 100-hour fuel moistures are dropping down. And the other thing,
yeah, this is all great information that I'm one of the fire weather program leaders at our office. I was not aware of a lot of this stuff because I'll be honest with you. Sometimes, you know, those graphs that you showed for the predictive service areas, they are very helpful. I've learned how to read those a lot more in the last couple of months and year or two. And Benny's been helping me with sending me some stuff for after action reports on fire conditions that we've had. But seeing it in a gridded fashion or a semi-gridded fashion, I guess broken up by the predictive service areas, is certainly a little bit a little more helpful, a little more approachable for the rest of the staff. Because some of those charts can get quite busy, and you know, it's like, which line am I looking at? What threshold am I supposed to use? This is certainly helpful, and it's predictive. You know, those graphs are more of a here's what's happened in the past, you know, up to year to date or the last several months. But this is really helpful going forward in time.
Yeah, and this is more of a medium range, you know, just a guidance tool. So, you know, and the other thing, if I see if the fuels are, you know, the yellow or brown dryness levels, and I start seeing, you know, there's high risk triggers across the country, and not all of the geographic use these, but like, you know, like this Ben is the critical burn environment. So the Pacific Northwest, they have thresholds, you know, I mean, it's similar to, you know, the red flag warnings, but we want to try and integrate the decisions you guys are making on the ground with cooperation with the fire folks. You know, like if I see the RHs are, say, below whatever the 35% and we have wind, I will put like you'll see orange W's like down near you guys. But does it always line up with the red flag warnings? No, you know, it's not meant to be like, you know, it's really just an augmenting the products that you guys in the Weather Service are putting out. But just be aware, like, I'm also looking at the weather elements besides the fuels.
Sure. And what do those different letters stand for? You said wind, the H, humidity.
You just like I think, let's see, I'll go to Eastern area. So it's just, you know, it's a general, like, you know, sustained 15 or greater 30. That's just kind of a overall standard that is used for our geographic area. And then like like hot temperatures with lower H, like that's just another hot and dry. And then the recreation would be like, you know, fishing opener 4th of July, where we could have an increase in human starts.
Sure. Nice. Yeah, this is all great stuff. And if you could provide us with some of these links, I'm sure we can figure out a way to get this out to the folks who are watching. Bennie, going back to your presentation for just a second, you don't have to reshare it or anything, but it was really interesting to see the effect that the new NFDRS has on your operations, sort of the triggers that you all have, given those values. It kind of harkens back to what we use in the Weather Service with operating plans and you know, for example, severe weather operating plans. If the SPC will issue this outlook, this is how we're going to staff things, and this is how we're going to message things. And it's good to see that that's not that. I mean, we knew this wasn't just our agency, but it's good to see that that y'all are also of in a similar structure when it comes to triggers and things like that. So I didn't know that, and you know that's great for me to know as a partner that, you know, that when these values start to creep up, this is what they're doing on their end to sort of, you know, mitigate their risk and protect the forests. Also, and to what Steve was talking about, I've been frustrated a lot with the visualization of dead fuel moisture and the ERC and on the current website. It's, you know, becoming a lot patchier. I know we're moving the resources over to WIMS, and so, you know, things are starting to not be supported as much. I cannot wait for WIMS, because now we will be able to actually visualize this data in a lot more robust standpoint. One question I have is there going to be a function for archived data? So can I go back and look at 2 or 3 months ago and check the fuel moisture from those times on from a gridded standpoint or a point standpoint? So you know, because our focals will do not event summaries, but year-end summaries. So we'll want to go back at the major events that we had and sort of pick apart the fuel moisture and see where things were most critical. Is there going to be an archive component to this as well?
I think there is. And for sure, you're going to be able to download the hourly data from the RAWs going all the way back. And I think, like it said in that PowerPoint, the data that's being QC'd and gap filled, it goes back to 2000. So, you know, a 23-year, yeah. And I'm pretty sure, you know, looking at archive data visually within FEMS, I'm pretty sure that'll be a feature, but I can double check on that. But you're right, it's going to be much more of a visual type interface, FEMS compared to WIMS. So I'm excited about it too.
Yeah, and currently we can get that information to you out of WIMS as well. If you needed any information, any events that come up that you want to look at from the fire behavior side of things, that we can pull that information as we wait for the onboarding of the FEMS program. Steve, do you know, you got the RMA dashboard on your, that you can share?
Yeah, let's see. I'll try and find it.
Okay. So the RMA dashboard is the risk management dashboard that we use. It's new, that's kind of onboarded, but I believe that one of the spatial displays that's in there, that's severe fire danger display. I think that's what some of FEMS is going to use as well. So I just wanted to bring that up because it also gives somewhat of a forecast on there. So yeah, if you click on the screen, just click on the screen, then go over there to severe fire danger. Yep.
Yeah, so this could be another link, you know, so let me scroll out.
Yeah, middle of the country. And so if you kind of like spatially that you can do on the Weather Service site, where you can see how the weather, the temperature is going to change throughout the week or 7 days, you can just hit the start button over there or the play button over there, and it'll show you throughout the week how the fire danger indexes will change based off the weather and information that they're pulling. So, but I just want to show you that display, and we can share a lot of these links with you guys as well. I mean, they're all public links. So.
Awesome.
Yeah, and this.
Yeah. No, go ahead, Steve.
No, this and the fire danger, this mapping system, like Matt Jolly of the Missoula Fire Lab is was the main impetus behind this. And this is basically replacing those old WFAS, the what does that stand for, Benny? Like assessment system, wildfire assessment system, the old like observe fire danger and forecast. This is basically the forecast ERCs and a combo of ERC and burning index. So you're combining kind of like the fuels with any wind and lower H's together into one index. So down here it goes out 7 days. So again, this is using the gridded, weather modeling coming out of the Weather Service and combining that with NFDRS to produce this.
That's excellent. Yeah, those were the maps I was talking about, the WFAS maps that are becoming a lot less helpful as we get closer to
the reason for that is once the old fuel models, the legacy ones, are pulled out of WIMS, they're not showing up on there anymore.
That makes sense. Yeah.
That's why they need to pull those maps off that. But this map is not on the WFAS site right now because they've got some weird. See these like Easter egg kind of things going on. So I think they're working on the fix, and then that I believe will be placed back on the main WFAS site.
Yeah, and I've seen those before. Is it kind of like a radius of influence from the different points? Is that kind of where that's coming from?
In those old maps with the little triangles where the raws were, they just have like orange around. I don't know why this is occurring, but I think that one of the benefits of this whole version 4 NFDRS transition is, like you guys are just talking about, is the updating of all these, the fire danger operating plans like Bennie displayed, like just updating the science, I think, and then taking that and helping it, using more of a quantitative system to make these fire management decisions. And
absolutely.
The other thing I wanted to pass on version 4 is the calculated dead fuel moistures, like the 10, 110s, hundreds and thousands. Those values, and I've gotten this from other fire weather focal points in the central region. When people are trying to verify like red flag warnings, it's tricky because the new system that calculates those, they've been like 10 to 15% higher than what people are expecting. So like, that's just something that we're gonna have to work around. But just make people aware within you guys' offices that those values are higher than we saw with the legacy system.
Right. Yeah. And I'll be honest. We tell our forecasters, just don't look at the forecast fuel moisture, because it's almost always wrong. And when it comes, and it's unfortunate, but using your best judgment, if it's going to be dry, if it's going to be windy the day, that day, those fuel moistures are going to take a tank and look at the trends, and not so much the forecast that's out there. Because I agree with you, they're not too useful. And when we're verifying red flag warnings, we look back at those and we say, yep, that was wrong again. It was off by a solid 10% sometimes.
Yep.
We do the same thing when we get your RH forecast from the National Weather Service when we're out burning.
Absolutely. No, I know. Knock off at least 5% sometimes, right?
Right.
But hopefully, with the new system, we can hone in those parameters and maybe restructure the the red flag warning system with some new fuel moistures based off of the outputs that will get out of either FIMS or get out of Fire Family Plus with the new models.
Absolutely. And I know that's something that's a conversation that's being had on a national level, is reassessing the red flag warnings in general,
Yes.
you know, and making the criteria a lot more, not necessarily uniform, but tailored to the location, and a bit more rooted in deeper science, deeper fire weather science.
Yeah, and instead of like the 8% for 10-hour fuels,
Right.
just that criteria, like, you know, it might be like your energy release components at the 80th percentile or something like that.
Exactly. We're coming up to the top of the hour. Mike, do we have any other questions from the rest of the attendees?
No, nothing on the screen, so I think we're good.
Okay. Well, then I'll call it, unless Benny or Steve have anything they want to add. I'm going to call this a great webinar. Benny, Steve, I want to thank you for taking the time this morning to talk to us. Again, this is going to be recorded, so we'll have this in perpetuity. And if you have any links you want to share with the rest of us, you can send them to me or to Mike or Randy, and we can get those out to folks. But again, Bennie, Terrell, and Steve Marien, thank you so much for joining us, and thanks everybody for listening. And we'll see you again next week for the next iteration of the guest speaker series.